Hey guys, I'm just going to make this short video about question 5 from assignment 11 for our statistics class. One of the reasons I wanted to go over this question is both because it's a little bit complex and because the help function for some reason appears to be not active on this question. So I thought that we would just go through each part of the math together and I would walk you through it fairly slowly, step by step. The question actually won't fit on a single Excel sheet if I copy it from Pearson. So I have just typed it out here, but you should be able to follow along even though it's in a slightly different format. Your question will have different values, but all of the same math will apply, so don't worry about that. So in this question, we're told that 47% of college students have unpaid internships. And this statistic here, this 47%, this is our P, or our population proportion. We've either sampled every single college student at one point or enough of them that we've been able to make this 47% judgment. But then we're told about a recent survey in which 100 college students were interviewed and 51 had unpaid internships. And now we're asking, we want to know, is our original hypothesis of 47% correct? And we're going to use the p-value approach at a 0.10 significance level to determine whether the proportion of college interns that have unpaid internships is different from 0.47. So in the first part, you'll be asked to state the null and alternative hypothesis. And I just have those up so that you don't have to watch me struggle trying with all the special characters in the type. That's what they are. It is a two-tailed test because we're not interested in our survey to know if it's more unpaid internships or fewer unpaid internships. We just want to know if the null hypothesis is wrong. It doesn't matter in what direction. So the first thing we're going to do is we're going to just read the question and we're going to pull out all of our variables. So the population proportion, we're told that that's the 47% of all college students everywhere in, let's say, in Canada. So we can fill that out. That's 0.47, or 47% expressed as a decimal. Next, we need to know the population proportion. We need to know the sample proportion. So this is the proportion of people in our sample who had unpaid internships. So we can press equals, and 51 out of 100 people had unpaid internships. Now, I did do this question several times while I was making this video, and I did occasionally get different, you won't always get a nice neat number like this one where you can easily tell it's out of 100%. The number of people in our sample is 100, and our alpha or significance value is 0.10. So now we can apply this formula, and this formula will allow us to find z, which will allow us to find our p-value. And I've got this split up into 4 steps that I would use just so I can walk you through it slowly, so I can show you where all of the math comes from. So we're going to start with the top of our equation, p hat minus p, or the sample proportion minus the population proportion. Next, we're going to handle the bottom underneath the square root. So this is going to be equal to the population proportion times, open bracket, 1 minus the population proportion, close bracket, divided by n, the number of people in our sample. Next, we need the square root of that number. So we're going to press equals, use the square root function, number, close bracket, and we're going to get 0.50. So now if you think about it, this 4, or this 0.04, this square is the top of our equation, and this square is the bottom of our equation. So now all we need to do is divide the top by the bottom. We can press equals, select here, divide by the square root of the bottom of that, and we're going to get 0.80. And this corresponds to our 2 z values on our empirical graph, and please excuse how I drew this. I'm not an artist. Um, so we need to find out what the area is underneath these two. This is a two-tailed test, so we need to find both these areas. And since they're identical, we can find it really easily. Since norm.s.dist will give us the area to the left. And instead of worrying about anything over here, we can just find this area and multiply it by 2. So we're going to press equals norm.s.dist. We'll double-click to complete. And then even though this is a positive number here, we want to take the negative number. We want to take this number here. So we're going to take the negative z value and its cumulative, and we close our bracket. So this is the area underneath this part of the standard normal curve. And now we need to double it. So we're going to press equals, and we're going to multiply this by 2. And we're going to get 0.423. And that is going to be our p-value. I'll just show you the correct answers over here. So now that we have that, we need to know, are we going to accept or are we going to reject the null hypothesis? So since our p-value is greater than a, we can see that 0.4 is clearly greater than 0.1. We're going to accept the null hypothesis. There's no evidence that exists that we shouldn't, because p is greater than a. So then, for the second part, because we've done all this, we can actually just do the second part really quickly, now that we have all this set up. We're going to select this and copy it over here. We're asked this time, however, though, that we're told that it's 59 out of 100 college interns. So we're going to press equals 59 out of 100. And that's going to give us just a slightly different value. And because we've finished all of these equations, we can just press here and copy this. And this will automatically fill out the new chart. And if you wanted to, what you could have done once you had this set up, is you could just have changed this to 59. And it would give you the same answers over here. And this is going to be kind of the same thing. So we have 240, and we're going to find this area under the curve. Multiplied by 2, it's going to give us 0.16. And we can see that this p-value is less than a. 0.016 is less than 0.1. So in this case, we're going to reject the null hypothesis. There is enough evidence that the null hypothesis isn't true that we're going to reject it. And I'll just show you here. These are the right answers. And that's everything. That's how you do this question.